doing number 3, and you'll notice when I read this and draw it that there's something different about this one. I'm drawing my axes. And it says in number 3, the velocity of an airplane with respect to the air is 425 kilometers per hour in a direction of 45 degrees north of east. Okay, so I take my protractor and mark 45 degrees here. And the value is 420. I'm going to make each of these count. Let's see here. 50. 1, 2, 3, 4. Okay, so that's my first vector. This is 45 degrees and this is 45 degrees. Okay, now the wind is blowing northward 75 kilometers, so I'm going to go north right here with the wind. So this is my resultant vector. And this was 425, and this was 75 kilometers per hour. Now, if you'll notice this, the resultant is, well, this whole angle, or this whole triangle, doesn't have a right angle in it, right? Okay, I'm going to help you fix this, okay? So what we need to do to find the x and y of this one is to make an imaginary line down here. Okay? Now we know this angle. Now this is where we're going to get into sine and cosine, okay? And remember yesterday I said sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. We've used tangent so far to find the resultant angle. But we have to find the x and y of that because it's at an angle. Okay? So we're going to say, if I find the y value here, I've got the sine of 45 is opposite over hypotenuse, which is the 425. Okay, so that means my opposite is going to be the sine of 45 times 425. Or 300. So this right here is 300 kilometers per hour. And my x is going to be the adjacent of the cosine of 45 times 425. And it is 300 kilometers per hour. Okay, now, if you have a 45-degree angle, yes, both of those sides are going to be equal. But if you throw in a 35-degree angle, they're not going to be, okay? So we're going to go back here and we're going to say, we're going to use our x and y's again. This one right here has an x of 300 and the y is 300. I mean, there's no y on this one. This is 300 on the y and no x. And then we have to look at the 75, and I'm going to say there's 75 on the y-axis, and there is no x on the 75. So I'm going to add all these together. And I'm going to go back and I'm going to use c is equal to the square root of a, and I'm going to choose this as a, plus 375 squared. And I get 480 kilometers per hour. So that's what this is. Now, that is that's the length of the resultant, okay? Now, there's two ways to go about this to find, we're going to use tangent, okay? And tangent okay, so this would be the opposite, and this would be the adjacent, okay? So we're going to say 375, the opposite. Theta is going to be the inverse tangent of 375 divided by 300. (51 degrees). Now we're not done there. That's not my final answer, okay? 51 degrees is this whole thing from the x-axis to the resultant. But what angle do I need to find? This little itty-bitty one. All I have to do now is say 51 minus 45, and I get 6 degrees. So my final answer is going to be, no, I take it back. This is, but we'll have to know, we either got to know this one or this one. We could say 51, this tiny one is 6, but if we measure it from this axis, it would be 51 degrees north of east. Or we could take 51 and subtract it from 90, and we'd get this angle right here. Okay? Questions? Is it here, Brady?
It's right here. We get down with it like it.
Okay, okay. Anybody else need to go that mentoring thing? No, okay. Now that's just one problem, y'all. It's kind of like stoichiometry in chemistry. You can use the whole page. Yes, baby. Because I either need this whole angle or I need this angle. Okay? I could say 45 minus 6, and it would be 39, would be this angle right here, 39 degrees east of north. Okay?
How do you know which one to use when it's like the 300 and 375? I was kind of confused.
Okay. Think of this as just a great big triangle. Okay? So this side here would be opposite of the hypotenuse, and this side here would be adjacent. So I had to add both of these together because they're going in the same direction.
So like when you added it and it was on the y side, that's how you. I was just confused
Yeah.
about like.
Yeah.
I don't know. I just didn't think of it.
And please ask me questions if you don't understand. Okay. Yes. Because you have to tell you where it's at from an axis, okay? So you could either tell me this whole one or this one from here to here. And you know that that's 90. So you could take 51 from 90 and get the other one. Now,
This entire thing is a result.
okay, now, I'm gonna do one more of those with you. Look at number 3 on the back of the first page, the first page. And then I'm gonna have y'all work the rest of these problems on this. Some are like yesterday, and then there's gonna be another one like the one we're doing today, okay? So I'm gonna do number 3 with you, where Peyton's a clown. Okay, so number 3 says, during a rodeo, a clown named Peyton runs 8 meters north and then turns 55 degrees north of east and runs 3.5. Okay, so I got my axis. And Peyton runs 8 north. I've got each centimeter equals 1 meter. Now I've got to measure my angle from here. Okay? So he turns 55 degrees north of east. Yeah, so I'm going to go 1, 10, 20, 30, 40, 55 north of east. And he goes 3.5 from here. And we have to find the resultant, which is that. This is, he went 55 degrees north of east. So you put your protractor where it's starting and pretend like there's an x-axis here and measure up 55 degrees. Now, once again, I'm going to make an imaginary side here of this triangle. If you have any line at an angle, you can make a triangle and figure out what the x and y are, okay? I know that this one is 8 meters. I know that this one is 3.5 meters. Okay, so I need to know this y and this x so I can add them to this. Okay, this first one here is 8 with no x, but this one here is going to have an x and a y. So let's find the y. We know the hypotenuse, and what is this angle right here? What's this angle right here?
35.
It's 35 plus 55 is 90, right? Okay. So I'm going to say for my y value, I'm going to say, let's see, adjacent well, that the, hold on just a second, cosine of 35 degrees times the hypotenuse. And my x value is going to be the sine of 35 degrees times my hypotenuse. I'm going to say 2.9 meters. And it's 2.
Like, how do you get like the sine and cosine stuff again? Like, I have it written down like.
Okay.
How do you decide?
So sine of theta is opposite over hypotenuse, okay? And cosine is adjacent over hypotenuse. Now look here, I'm looking at just this little tiny triangle, right? My y value is adjacent to the angle, it's the side of it, okay? So I have to use this for my y value. And I'm going to put 35 here and 3.5 here and just multiply them together to get the side value, the y value.
The adjacent?
Mm-hmm.
Okay,
Mm-hmm.
that makes sense.
And then the x is opposite the angle I'm using, so I have to use the sine. Okay, so I have 2.9 here and 2 here for that specific line. So this is 2 and this is 10.9. So this is 10.9 and this is 2. Okay, 10.9 and 2. So now I use Pythagorean theorem and say the square root of, it doesn't matter, 2 squared plus 10.9 squared. And then take the square root of it, and I get 11. So that means this right here is 11 meters. But I got to find this angle or this angle, either one of them. I'm going to go for this one because I know my opposite and I know my adjacent. So I'm going to say the angle is the inverse tangent of opposite, which is x, 2, over adjacent, which is 10.9. And I get 10 degrees. So my final answer is 11 meters, 10 degrees. What's my direction? East of north. Okay. Now, take that sheet and I want you to work the rest of those problems. 1, 2, 4, 5, and 6. Okay? You're going to omit number 2 because I failed to give a direction for, I failed to tell where Allie was. Okay? I must have taken some of that out and didn't know it. So omit number 2. Omit number 4. I don't have enough information on that one either. Just 2 and 4, omit them. Oh, 5-2 because that's projectile motion. Forget that sheet of paper, because it's projectile motion. And this is too. Okay, I'm gonna make one up for you. Now, just keep that paper, because we'll do projectile motion Monday. Okay, so we're gonna say that Warner flies his plane, that's misspelled, at 425 kilometers per hour, 25 degrees north of west. Okay, he's going to Alaska. He then turns and goes due north at 350 kilometers per hour. What is his resultant velocity? Okay? Work that one. Mm-hmm.
So I know the one going north of west will go like this. So does the one going due north just go straight up?
Mm-hmm. But I think you made your angle too big. You measured it. The 25 degrees was north of west, not west of north. So you have a big angle at the bottom when it should be a smaller one. See, like this. You measured from here over, because you have a big angle down here, okay? So you need to measure this one up this way, okay? Mm-hmm. Yeah.
Okay, so you know we do sine and cosine
Mhm.
on these. Okay, what if the opposite and the hypotenuse is the same?
I didn't get that.
You didn't.
I got these two values. I got my x is 380 and my y is 385 and 180 here, and then I
So
added
how do we do this?
this side here is cosine of 25 times 425. Okay.
Yeah, I was just looking at it wrong.
Should I do this one? Because I don't know.
Okay.
What I was supposed to do?
Yeah, but this one right here should be up here, like this, because you have to put them tip to tail. So you're trying to find that one. You can't just stick it on the, okay? They gotta be tip to tail. So you do the first one, then the second one has to be from the tip of this straight up.
So we're just finding this, so we don't gotta do all the same. We don't
You
gotta
have to do
all that?
everything. Mm-hmm.
Alright.
Because this has got an X and a Y. Mm-hmm. Gotta do it already. Sorry. I like your hair. Yes.
Yeah, like 550 I'm not.
Mm-mm. This right here should be, this would be cosine of 25 times 425. And this is sine of 25 times 425.
Oh,
yeah. Okay. Well, that's all right. And I'll draw your result.
Oh, so that was, I was supposed to. I didn't know, I just looked for my. So is that when you sit in a dress that has a hypotenuse? How do you find the little sign coming out right there? Right, so we just have to do it like.
When you get those, the sine one is gonna be the y value. That's gonna be x value. So when you add these two together, it gets the y value for this whole angle.
Wait, for which
You
one?
know how I did it for this whole angle, where the resultant is.
Oh, so like,
Okay.
that right there?
Uh-huh.
Okay, alright, that makes sense. I just have to like, so like.
It just takes a little bit. Yeah, and that's gonna give you that.
Okay, it's gonna be y.
Yeah, because, and then you're gonna add those, remember I did the x or y thing? You'll add these two together, to get the y, and the cosine's gonna give you your x. I'm coming, Molly. Jackson, how you doing there? Did you see it? Okay, let me make it bigger. Hold on just a second, I gotta make this where you can see it. Can you see it now, Jackson? Okay. Trinity, I'll be right there. Second. Yes, baby. So you said, 125, 6 times 425. Because these two multi-times 100 are opposites, and I made that 180. Okay?
So at the end, like, I got four, and we add these to it, and then we like that.
Yeah. This is your opposite, this is your adjacent. So inverse tangent, yes,
I was just making sure.
yeah. So this is. So this is design. And then you put the address. And this is only address. And then these two. And then these two addresses.
I mean, it's nice place. Honestly, I've sat with it propped up, I sat with it propped up pretty all day. I'm not.
Yeah, I didn't think this was.
Try it, baby. Yes, I think that video is still running. Think so? I never checked my number. You know, I'm old, I forget from the time I walked back there. Okay, so I got 655 at 54 degrees north of west. Is that what y'all got?
I got 50.
Huh? You got what, baby?
I got 50.
Did you say inverse tangent of 530 over 385?
No, I didn't.
Yeah, you can't use that again.
How do you do the angle for it again?
Okay, so this is your X, right? And this is your Y. So you're gonna say
Yeah.
you can't inverse tangent of Y over X. One of these add together, so it's gonna be 530 over. It gives you this whole angle, and then I see here. You don't have to subtract, 54 is what I got. Yes, sir. So this is your X.
said north of west or north of south.
Okay. I'm gonna let you rest your brain for 2 days and we'll come back Monday and I'll have some more problems. And then we're gonna start projecting on Monday.
Every time I come to the grass, my brain is just a little bit more.
Is that good? This is one of my favorite ones. But
Stuff I don't think about though.
just don't panic, we'll get it. I don't think it's good though. Because every time when we start something, we don't have a panic, you know, what I'm saying?
Yeah, that's what I said too. Somebody asked me about that and I was like, so more I like it better. And I think it's chemistry, it's like, you can rearrange and all this other stuff.
Almost like a circle,
Yeah,
you know, it's not real.
well, it's like more
Yeah.
ish, I don't know, kind of.
I love it. How you doing, baby? Are you okay?
I'm sure, like, theoretical. Yeah, I would.
But if it, oh, no, if you got that one, then it would be west of North. It'd be either 54 north or west of North. West of North.